In this video we're going to look at flexible pavement construction in a little bit more detail. Obviously flexible pavement is an important part of New Zealand construction, so you need to know about it a little bit more than some of the others. So the first part of most earthworks, most roading projects actually start with earthworks. So we looked at earthworks in the previous videos, shaping the ground to the appropriate profile required for the road, stabilizing the road, making sure that the subgrade is strong enough to take the road loads. You need to test the subgrade before you start building the road on top of it, and the way we do that is the CBR, Californian Bearing Ratio, and test rolling as well. There will also be shear vane tests and other strength testing to make sure that the road is actually strong enough, and so that'll be testing every 20 meters or so to make sure that the road is actually up to the right strength. So there's CBR testing there. It basically measures the deflection of, in this case it's not a road, it's just some soil, but it measures the deflection under a certain load, and it should be a certain value for the road, and that will all be set out in the design documents, or the contract documents. Test rolling involves just basically letting a roller go over top of it, watching it. Does the ground actually bounce back? Does the roller make an imprint into it? Does the ground weave? So you're looking for all of those things there to make sure that the ground is actually compacted to the right level. To improve the subgrade, it may be that the subgrade's not strong enough, so you may need to have a thicker pavement, you may need to put more drainage in, you may need to do stabilization, which we looked at in the previous video. Also need to set it out. Remember that a road has camber and super elevation, has a certain width and things like that, so they need to be set out properly. In the past, it's every 20 meters or so there'd be pegs like this, which allow you to distinguish how far the edge of the road is from those pegs. So this one here would be offset, say 300 mils to the edge of the curb and channel, and on these you would also have the profile to allow you to string line the camber of the road to get it to the right shape as well. Nowadays it's becoming more and more popular just using GPS, so a lot of sites now you won't even see any pegs there. It's all being done by GPS, so the grader has GPS loaded into it and it will shape it to the correct shape. Underground services, it's always a good idea to get the underground services in before you start building the road. Sometimes you've got no choice, sometimes you have to build the road then put the services in before you do the sealing, but usually what you try to do is put the subsoil drainage and any culverts and stuff in, and then build the road on top of them. Any channels need to be cut. You normally cut those before you start putting down the subgrade as well. Once again, you don't want the soil mixing in with the aggregate, so it's best to do all of the earthworks, shaping channels and things like that before you start putting down the aggregate, because when aggregate gets dirt in it, it's not suitable for structural support anymore, because the dirt reduces the strength of it, and therefore it needs to be removed. So do all the earthworks first, then start putting the aggregate down. You can see here they're laying the subbase. In this case here they're just dumping it, but normally what happens is the truck's actually rolling along, tips the tailgate and lays it in a thinner layer. In this case here they'll have to move it around using a grader or something like that, which is not very good because it can cause segregation. Once you've laid the sub base, you will usually build, if you're doing an urban road, you will usually build the curb and channel on top, because the base course is normally built constrained by the edge of the curb and channel. So you need to lay the curb and channel, let it cure up to the required strength, and then you lay the base course on top of that. Once you've laid the base course, obviously you lay it from the trucks, and then there's a rolling and shaping. So the roller and the grader usually work together, with the roller compacting it down, the grader coming along shaping it, the roller going over top again, and just carrying on until you've got the right shape and the right compaction at the same time. You can see here they're using a vibrating roller with wheels there to make it a bit quicker. You can see there's still a little bit more compaction here. You can still see the roller tracks after each pass, but it's almost up to the right standard. Trimming the base course, you can see here a grader doing side casting, so he's shaping the base course, moving it into a windrow, and the operator will have, you can see there's little marks on the ground there, which is probably something like, you know, up 5 mils or down 5 mils, telling the operator how much needs to be removed. So that's what those little pink spots are on the ground there. Nowadays it would probably be done with GPS. He'd probably have a GPS unit there telling him what he should do. In the old days you'd string it and then you'd be writing the cut or fill on the road, but nowadays with GPS not required. Also you're testing the base course, making sure it's to the right compaction. Nuclear densometers are quite a popular way of doing that. In the past there was sand replacement methods and things like that. So you're looking at the density of the base course. Is it the right density? Is it the right strength? Once you're preparing it for sealing, you will actually go through with a PTR to sort of roll it down. And what you're doing there is you're tightening up the surface of the road so that you're getting that stone mosaic finish. So the surface needs to be especially tight because there are shear forces when cars start accelerating. The surface layer of the base course is resisting those lateral forces that are trying to flick bits of aggregate out of the base course layer. So it's really important that the surface of the base course is tightened up, and a PTR, pneumatic tire roller, or a wobbly is the ideal machine for that. Preparing for sealing, you can put a PTR over top of it. Another way is to let cars run over top of it. You can see that cars actually have pneumatic tires and they actually do good compaction, and so oftentimes you'll move the traffic using cones back and forth across the road so that the wheel tracks are moving across the road and you're getting a little bit extra compaction. If you've got cars sort of using that road, why not use them? Sealing. So once you get to the sealing, you lay down the bitumen, and you've got a special bitumen truck that is hot bitumen, so it's 150-200 degrees Celsius, can cause very severe burns, and when bitumen hits you on the skin, it also sticks, so it's very hard to get off. So precautions need to be taken when using bitumen. It can cause all sorts of problems. And you can see that there's a truck following along behind laying the seal. So the bitumen is laid, and then the truck is backing along, laying the bitumen as he goes. Sorry, laying the chip as he goes. And then you have the PTR going along and tightening up the chip. So what you're trying to do there is you're trying to get the chip layer to form into an interlocking layer as well, which makes it just that much stronger. Remember that the surface has cars accelerating and braking on it, and each time they do that there's a lateral force there that's trying to flick the chip or whatever it is out of the surface. So it needs to be tightened up, and that's what the PTR does. Here's what a PTR actually does. So when the chip is laid, it's all standing up. Some of them will be lying flat, but most of them don't. So when the PTR comes along, it's providing a kneading action and causing those stone chips to start rolling over and locking in together. So you can see they're starting to roll over there, and then they're all locked in together. They're all lying flat. So that's what a PTR does. And then you can see that the stones are actually, the chip is all supporting each other. It's all locked together and provides some resistance to those braking and acceleration forces that I was talking about. And finally, after a while, there'll be excess chip there. You always lay it with excess chip because to make sure that you get good coverage. After a few days, when the bitumen has hardened, you will go through with a sweeper to sweep off that excess chip, so there's no loose chips sort of flying around breaking car windscreens. So sometimes the layer, this top layer, will be sealed in AC. You may do a seal, a chip seal, and then a few months later you'll come along and put AC over top of it, or it may be that you're laying AC straight onto the base course. And so you can see that what we've got here is a large paving machine. There's the hopper in the front there. Trucks are coming along from the bitumen plant. They're tipping the hot mix into the hopper. There's a screw conveyor spreading it along the whole width there, and then there's something leveling it to give it that nice shape there. And you can see that guy there is continuously adjusting the level there to make sure that they're getting the right shape and everything like that. And after you have laid it down, you'll come along with rollers and roll it to get the correct compaction. However, AC doesn't compact down very much. It's already quite a compact material already.